Hi, welcome to another video. So this is a Mackie SRM350 version 2, and you might see the little label up here. I think October 16 I replaced the FET driver and 2 base FETs because they'd gone short circuit. It came back to me a year later, and it's taken me a year, or best part of a year I think, to get this going. I'll give you a look. Right, so looking at the component side, switch mode power supply, plus or minus 75 volts, just like most of the other Mackies, like 450, etc. Mains comes in here, got a mains filter under there. Mains comes in here, plus or minus 75 volts for the bass, plus or minus 39 for the treble chip, and I think plus or minus 15 for the op amps. Now the best thing about this version 2 is if the base goes short circuit, this power supply protects itself. One of the best things they've actually done. No PFC circuit, so it's not going to blow up, so they are fairly reliable power supply wise, but unfortunately the base always blows up. Now if you've seen any of my Mackie repairs, you know this is the coil that takes out the 400 kilohertz. It's just an air-cooled coil, but for some reason they've stuck it in a can. That's the coil to take out the 400 kilohertz to the bass. So we've got bass and treble here. As I say, there's a treble chip, input down there. The input board is underneath the power supply down there, just down there. So there's the input lines here. So the important part for this video, there's the 2 bass FETs. They ordinarily sit on this heatsink, which is part of the back plate. These 2 base FETs, driven by this FET driver, and I've used these on switch mode power supplies before, and they are notorious for failing if there's a problem with the base FETs. If the slightest hint of a fault with one of these, it will take this out. So if you've got no base and no power supply, check the base FETs, they're probably short circuit, and if they're short circuit, change this as well. So the problem with this board, usually you just change this FET driver, 2 FETs, job done. If I turn this over, I've had to extend this. As I say, I've had it for best part of a year, couldn't get to the bottom of the fault. This is 5-volt regulator, that was working. Various, you can see quite a few surface mount components underneath. 5-volt regulator, 555 for the sampling, but this tiny 8-pin device is a TC7W04. So the problem with this amp was this inverter here, high-speed CMOS inverter, 3 inverters in one package, 8-pin. Now if you look at the tip of this smallest soldering iron I've got, you can see why I had trouble. I soldered this in using a magnifying glass and one of these. Thought it was on there, and so roughly a year ago, still didn't work. So I've extended the board with 12 wires, turned it up the other way, probed it today, and other days, but probed it today, tracing the signal, and there was no signal going to pin 1. And the actual fault was pin 1 was sitting on top of the pad but not making contact. So I fired up this small soldering iron. This soldering iron would actually touch 2 legs together, but you have to be careful, just touch the outside one. I initially used a heat gun and some solder to put it on initially, and a quick look, I thought it was all okay, but it wasn't. There was the pin 1 was not making contact. Well, so now I've got signal going to this FET driver. I only had one base FET, 31 and 20. I think they're the same as the 450s. I only had one. These are rated at sort of 31 amps, 200 volt range, something like that. And I've been messing about with these Infineon 700 volt on the PFC circuit. Now these are a newer FET, quicker rise time, quicker fall time, lower capacitance, half the current rating really of this. But I only had one of these, so I thought I'll give it a go. There we go. we've got an output a year later. So some of this jitter is the 400 kilohertz because I've got a low input signal and the volume's not turned up because the FETs aren't bolted down. So this is that tiny 8-pin package. I'm not sure what the package is called, but it's the smallest I've done, and the first time I had trouble. As I say, pin 1 wasn't touching the pad properly. So it's a triple high-speed inverter. And there's his circuit layout there. So I finally sussed that, got the amp going. Yeah, so that's a dilemma. Do I stick 2 of these in? I think these are actually slightly more expensive, but these fail and they take out these. These are £3 or £4 each. So these run cooler, not meant for this job, but they run cooler. This gets hot very quickly. Probably when the customers give them a pounding, they just cook themselves and blow up. And as I say, because I had so much trouble with this FET driver board, had to get 12 wires, mount it like that so I could probe every pin. Even this scope probe touches 2 of these legs when I was probing it, so I had to be really careful. Fortunately, the signal was going in on pin 1, so it was easy to just get the end. First time I've had trouble with surface mount devices, and that's the smallest chip I've soldered with the pins closest together. Anyway, so that's the rundown on a 350 and the quandary with the FETs. Do I change them, stop fitting the standard because they blow up, and fit newer type? I guess I'd have to fit 2, which I've got 2, bolt them down. I could do away with these insulators, bolt them straight to the case. It's a better heat conductivity, and give it to the customer and see if they last longer than the original. Thank you very much.